Hello dear students, my name is Devinder Kaur and you all are welcome to the Enlightened room. In this video we will discuss about covalent bonding in carbon. In the beginning of this video you all would be getting about what is chemical bonding, what are the types of chemical bonding, and then we will discuss about what is covalent bonding and why does covalent bonding or why does carbon possess covalent bonding. So we will go step by step in this video. So let's get started. So let us start our topic with chemical bonding. Since we are discussing about the topic covalent bonding in carbon, so we will first go with the word bonding. That means what is bonding or what is chemical bonding. So my dear students, chemical bonding is a kind of bonding which is present or which is found in chemical reactions occurring between any two atoms or molecules, not just two, more than two atoms or molecules. Okay, so whenever a chemical reaction is going on, so what is chemical reaction? Well, in case of chemical reaction, we would say let us assume we have an atom A, okay, and then we have an atom B, and these two are having a kind of chemical reaction. They are taking part in a chemical reaction, but to take part in a chemical reaction there should be some bond between them. These two would react with each other. When they would react, a bond will be formed, and after that bonding the process of chemical reaction would complete and they would form a new substance or compound. This is what happens in a chemical reaction, and for that certain temperature, pressure and other some catalyst or presence of some gas or heating, cooling, whatever it is needs. Okay, so we are talking about this. The reason why a plus sign is there to show that these two would react with each other and would form a bond, and that bond is chemical bond. Okay, so I hope you all are clear with what is chemical bonding. Chemical bonding is what? A bonding that occurs when in a chemical reaction, or the bonding that occurs when a chemical reaction is occurring. Okay, so to complete a chemical reaction, chemical bonding is necessary. If there is no chemical bonding, then there cannot be any kind of chemical reaction. Okay, so any compound, any substance or any molecule is being formed, it is because of that bonding, whether the molecule is from the same element or from different elements. Let us say we have H2. Now this H2 would be written as like this. Okay, this sign shows bonding. That means in these two hydrogen atoms is there is a bonding which is present here. Okay, another example is water. Okay, so I have this oxygen. Now this sign shows that a bond is present between them, and due to that bond this molecule has been formed. If there is no bond, let us say the bond has vanished, then the whole compound or molecule is completely vanished, because these are not linked with each other, these are not bounding with each other. That's why a bond is necessary. Okay, let us take another example. Let us say carbon dioxide. Now for carbon dioxide, this is also a bonding. Now this is double bond. It is considered as double bond. Okay, since we are talking about carbon, so let us take this one example as double bond, because the reason why I am saying double bond, you would get the answer in the end of this video. Okay, now we have cleared the topic chemical bonding. Now what are the types of chemical bonding? Chemical bonding is of many types, but according to our curriculum, according to our syllabus, we will consider about two types of chemical bonding, and that is, dear students, ionic bonding and covalent bonding, which is our today's topic. But before discussing about covalent bonding, I will explain about ionic bonding. The reason behind this is that if you are not clear with the concept of ionic bonding, then the concept of covalent bonding would be difficult for you. Okay, so let us take an example of ionic bonding first. Well, from its name, ion, it is clear to us that it is a bonding between ions. Now, how ions are formed? Whenever an atom, in an atom there is an outermost shell, and in the outermost shell, if the octet is not complete, that atom is unstable. So to maintain or to complete its octet rule, or in the attempt of getting stable, that atom would either lose its electrons or gain some electrons from other atoms or molecules to complete its octet rule, but in this process the atoms get converted into ion. I have said this, now I will explain this. Okay, let us assume, why I am saying consume today, I don't know why I am saying this. Let us assume, okay, let us assume we have sodium here. Now dear students, what is the atomic number of sodium? 11. Okay, so as per the electronic configuration, in the first shell there would be 2 electrons, okay, because of the duplet rule. Then it is K shell. In L shell, how many electrons are present? 8. Then in the M shell, how many are left? 1. Why? 11. Now why are we talking about its electronic configuration? Let us take a look. What is the meaning of atomic number? Atomic number means number of protons present in the nucleus of an atom. So that means sodium has 11 protons in its nucleus. Since sodium is electrically neutral, so the number of protons and number of electrons present in it would be equal. That means if it has 11 protons, it has 11 electrons, and these electrons are here. So this is the electronic configuration of sodium. So let us take an example here. This is the nucleus of sodium. Okay, it has 11 protons and there would be certain number of neutrons in it. Okay, we do not need to discuss about the neutrons. So in the first shell or K shell, 2 electrons are present. In the L shell, 8 electrons are present to maintain the octet rule. So 1, 2, 3, 4, 5, 6, 7, 8. Now in the M shell, only 1 electron is present. So this is our sodium. Now this sodium wants to maintain or wants to have this stability. So either it would try to get 7 electrons from someone, or it will lose its 1 electron. So which one is easy? Of course it would lose its electron. It's 1 electron, and this shell would be vanished and would be only left with this one. But in this attempt it would be converted into sodium ion. Now to whom it will give the electron? There should be some atom or molecule to which it would donate its electron or lose its electron. So let us assume we have chlorine here. Okay, so in chlorine, what is the atomic number of chlorine? It is 17, and it means it has 17 protons. Chlorine is also electrically neutral. All the atoms of all elements are electrically neutral. Okay, so since chlorine is also electrically neutral, if it has 17 protons, it has 17 electrons. So we can write its electronic configuration as 2, 8, 7. So here is our K shell, here is our L shell, and here is our M shell. Okay, so in this one we have nucleus of chlorine here, in which 17 protons are present. In the first shell, K shell, 2 electrons are there. In the second shell, 8 electrons are there. In the third shell or M shell, 7 electrons are there. 5, 6 and 7. Now, to maintain the octet rule or to attain this stability, chlorine will either lose its 7 electrons or would gain 1 electron from someone, would take some electron. Okay, so it is better that, of course, the easiest method is to get or gain 1 electron from some other atom. So it needs 1 electron. This one wants to get rid of that 1 electron, that extra electron. So of course, what would happen? The sodium will give this 1 extra electron, valence electron, to chlorine, and in this way the sodium would have completed or attained its octet rule. Similarly, and would have attained its stability. Similarly, chlorine would attain its stability. But as I told you, in this process, what would happen? The sodium, wait, let me write chlorine down here. The sodium, as the sodium has donated its electron, it has lost its electron, it has donated, it has done something good, it would have positive charge. It's a trick to learn. Sodium has donated its electron, it has done some good deeds. So the positive energy would be created, we would say it has attained positive charge, the easiest way to learn. And this chlorine has taken someone's electron, has gained and has taken someone's electron, and it has attained some negative energy and it would have negative charge. Also, the reason behind it is that 11 protons are there, that means positive 11, right? Now only 10 electrons are left. Electrons have negative charge, protons have positive charge. That's why 11 is positive is for 11 protons and negative is for 10 electrons. So if we solve it, we will get +1. So the +1 charge is here, over here. And in this case, 17 protons are there, plus now 1 electron is added, 18 electrons are there. So if we will solve it, there would be -1. Okay, that's how the charge is made. But we often tend to go for some easiest way or trick. Okay, that's why I use this trick to learn. Now since these two have created a bond between them, okay, now that bond is what? Ionic bond. Because of gaining or losing of electrons, these two have made a bond between them, and due to that bond they have taken part in a chemical reaction, and due to that chemical reaction a new product is formed, that is sodium chloride, which is also known as common salt, and the name of the bond between them is ionic bond. Now you would know how ionic bond is formed, by gaining or losing some electrons. Okay, now let's move on to covalent bonding. What is covalent bonding? But before that we will take a look at carbon. Okay. Alright, now let's discuss about carbon. Now this carbon has a symbol of C. You all would have studied that carbon is denoted by C. Okay, now as we in these compound or in these atoms we had first discussed about its atomic number. Now the atomic number of carbon is 6, right? Since the atomic number of carbon is 6, in the it has 6 protons. If 6 protons are there, carbon is also electrically neutral, 6 electrons are there. And if 6 electrons are there, we will have to arrange them in the orbits or shells. So first orbit is k orbit. In the first orbit only 2 electrons can be present due to the duplet rule. So 2 electrons are here. Now next shell is L shell. Now how much electron are left? 4. Okay. Now this is its electronic configuration. 2, 4. Now if we try to draw its diagram, we have a nucleus here. First orbit 2 electrons, second orbit 4 electrons. Now if you pay attention here, carbon can neither gain any electron nor lose an electron. Why so? Why it cannot gain or lose an electron? Now the reason behind it is that the valency or the combining capacity of carbon is 4. It is a large amount, okay. To form a ionic bond, 1 electron, 2 electron, and in some rare cases 3 electrons can also be possible to gain or lose. Now when it comes to the amount of 4, it is very difficult for any atom, very difficult, you would say, not so possible for any atom to gain or lose this much quantity of electrons, because for that a huge amount of energy is needed, and not every atom has that much amount of energy. Even carbon does not have that much amount of energy. Carbon is such a small atom. It has only 6 electrons. It has only 6 protons. So if carbon tries to gain some electron, no other atom would give it. Okay? Not a single atom is present in the complete periodic table that would have capacity or ability to give 4 electrons direct to the carbon. So the chances of gaining the electron are lost. Now if we talk about if carbon loses its 4 electron, now when it comes to this part, there is a effect known as shielding effect or screening effect. You would learn about it in higher classes, okay, in class 11 or 12. Due to that effect, due to the attraction of protons towards those electrons, because these two are unlike charges, okay, also a huge amount of energy. If in this state carbon tries to lose its first or second, this or this, any, even 1 electron, carbon needs a huge amount of energy to release. Okay, so let us say it would get some energy from some other atom. It would borrow some energy from some other atom to lose this electron. But still 3 electrons are present. How much energy that carbon would borrow? It is not possible for carbon. It is not possible for any atom. It is very difficult. So carbon can also not lose its electron. So what would carbon do? Since we have known that carbon can form huge quantity of compounds known as carbon compounds, and our earth is made of carbon compounds, even we are a carbon compound, right? So how does carbon form bond? How does carbon bonds with other atoms, takes part in chemical reaction and completely forms a carbon compound? Neither it can gain electron nor lose electron. So there is a different way for carbon. Carbon has made its own way to form compounds, and that way is known as covalent bonding. Now what is covalent bonding? If we talk about the definition of covalent bonding means sharing of electrons. Sharing of electrons. Now you all would say, ma'am or Devinder, what is this? In ionic bonding, what did we discuss? They also share their electrons. If I have a pen, I will give it to you. We have shared it. You have kept my pen. It's okay for me. I have no problem with it. You can keep my pen. Similarly, this one. Yeah, you can keep my electron. I have no problem with this. Even I am getting my octet complete and you are getting your octet complete. But this thing is known as sharing of electron. My dear students, it is known as transfer of electrons. Transfer or gaining or losing of electron. It is not sharing of electron. Okay. So covalent bonding means sharing of electron. So carbon would form certain atoms around itself, or most of the atoms around itself. It would find those atoms, would talk to them, hey, hi there, you want to form a bond with me? Let's share some electrons. Yeah, carbon would share some electrons. Now how it would share these electrons? Now for that, let us again assume we have an atom A and an atom B. Now one of them is carbon. Okay. Now this atom A, sorry about this. Now this atom A cannot lose or gain its electrons. That means let us assume A is carbon atom. Now there is another atom B. B said, oh, I understand your problem now. So what it will do, it will give one electron to it, but not to keep it. It will keep that electron here. B would say, let's share this electron if you also take your electron out for sharing. Then carbon or A said, okay, I will take out my one electron to share with you. So when these two would have electrons to share, a bond will be formed. Let's keep it simple. Let us discuss about in a simpler way. Let us assume you and me are in examination hall. Okay, and we are only two who know each other, and we are only one for each other to help. So in my examination paper and your examination paper, we need to make some diagrams, and it is mandatory to make those diagrams with pencil and write the other part with pen. Same condition applies on you. So I have a pen, but I don't have a pencil. So if I won't make the diagrams, my marks would be reduced. Similarly, if you would only make like if you have only pencil and you don't have pen, so if you make only diagrams and you would not write the answers, your marks will also reduced. So we are looking at each other, and there's an idea in our minds that let's share it. So I will keep my pen here, you will keep your pencil here. Whenever I need to draw a diagram, I will take that pencil and draw. Whenever you need to write the answer, you will take this pen and write this answer and then keep it here. So my pen and your pencil are on the desk, and we are sharing it to make a bond, to make a chemical reaction. That means to get our marks, to get good marks, and to complete our answer sheet, to solve all the questions, right? So same condition is being applied here. So in this one, these two would share those electrons. Okay, they would form a bond by sharing of these electrons, and when a bond has started being formed, a chemical reaction will occur and a new compound will be formed. Now the line between them shows that a bond is formed. Okay, now the covalent bonding can form single bond, double bond, triple bond. Let us say I have atom C and atom D. Now one of them is again carbon. So in this case, they have shared 2 electrons. One more thing you need to remember, if A is sharing its 1 electron, B will also share its 1 electron. B will not try to make 1 electron here and will say yes, we will share it like this. No, this is wrong. Equal number of electrons will be shared from both parties, from both atoms. Okay, if it's 1 from both sides, it's 1. If it's 2 from both sides, it's 2, and if it's 3 from both sides, it is 3. Okay, so if C would share 2 electrons, D would also share 2 electrons, neither 1 nor 3. So in this process, a bond will be formed and they will form a compound. Now we have E and F. They are able to share 3 electrons with each other, and a bond will be formed between them, and it is known as this covalent bond. Now if you pay attention, I have only one line here, I have 2 lines here, and I have 3 lines here between these atoms when the compound is formed. Now why is that so? Because it has only shared 1 electron. 1 bond is formed. It has shared 2 electrons. 2 bonds are formed. So double line. This will be shown by double line. 3 electrons are shared. 3 bonds are formed, and this is triple bonding. This only single bond is present, single bonding. 2 bonds are present, double bonding. 3 bonds are present, triple bonding. And as the electrons are being shared in them, the type of bonding present in them is covalent bonding. I hope you understand. And the reason why the covalent bonding occurs in some atoms is that because of low melting and boiling point. Okay, we had taken the example of carbon dioxide before. Yes, I am going off the topic, I know, but it just came into my mind. Okay, now if you see here, 2 electrons from oxygen are being shared like this, so double bonding. Okay, I would explain it clearly in the next video because the next video is about it. So double bonding is present here. Now I was on what topic? Yeah, why covalent bonding occurs in some substances or some atoms or elements. So in the case of ionic bonding, if you pay attention, whatever the compound is formed because of the ionic bonding, its melting and boiling point is extremely high. Also, the compounds formed by ionic bonding are extremely good conductors of electricity. Okay, it is a good example because in the conduction of electricity, electrons are needed, and electrons can be taken out from those atoms. Okay, so that's why electricity is conducted, and these are good conductors of electricity because they can either gain or lose their electrons. Also, they have high melting and boiling point. But in case of covalent bonding, their melting point and boiling point are very low, and they are poor or non-conductors of electricity. Okay, that's why a covalent bond is formed, because as they are non-conductors or poor conductors of electricity, there would be no gain or loss of electrons. Of course, the electrons are being shared. If this electron goes out from the bond will be broken. Then how the covalent bond will be formed? Okay, so a bond is needed, and it is needed due to the presence of electrons, due to the sharing of electrons. Okay, so today we have discussed about chemical bonding. What are the types of chemical bonding, what is ionic bonding, and what is covalent bonding. And still one more thing is left, the definition of covalent bonding, which will be displayed on the screen now. A chemical bond formed between 2 atoms by mutual sharing of valence electrons between 2 atoms, so that each atom acquires the stable electronic configuration of the nearest noble gas, is called covalent bond. And the number of electrons contributed by each atom for sharing is known as its covalency, and the compounds formed by the sharing of electrons are called covalent compounds. So dear students, we have today discussed about covalent bonding of carbon. I hope you found my video useful and you understood the whole topic, and we will discuss about types of covalent bonding in the next video. And if this video was really helpful for you, it was really useful for you, then do like my video and share this video with your friends and your classmates or batchmates. And if you haven't subscribed to my channel yet, please subscribe to my channel and press the bell icon. Thank you for watching.